Common architectural patterns. Firstly, this is a video about computer programming, so is unlikely to be of interest to anyone outside of that area. Also, it will be a PowerPoint presentation, you have been warned. I'm an old programmer who's been around for a while, and this video is just my personal view of common, top-level architectural patterns relevant to the world of development today. That statement itself implies the belief that architectural patterns can be layered. I am also looking at application-level architecture only here. I have searched the web for articles and pages on software and architecture, looked at a lot of examples, watched a lot of videos, and read a lot of posts. I have encountered a lot of common understanding, but also some quite different ideas and interpretations. Is there a single correct view or right answer? I do not know, so I will present my current views based on what I think and what I have found. I'm not even sure that patterns is the right term here. Perhaps they are types or just architectures. If they are patterns, then they are the top-level patterns, and whatever they are, other, lower-level patterns will exist within them. This is intended as a primer to just show a more complete view of the software architectural landscape. It is neither a manual nor a deep dive, just an outline. Obviously, any attempt to put such a large topic into a single short video will result in a very superficial coverage. At the end, there will be some links to places where more detail can be found for those who may have an interest in the subject. In discussions with other developers, it has become apparent that many programmers seem to buy into the current Microsoft architectural dichotomy, which classifies software as either a monolith or a microservice. This is clearly nonsense, but still a good starting point. In my search for information, I've come across sites, pages and articles that simply do not include the concept of monoliths and distributed systems in the first place. I found this strange, as that has always seemed to me to be the place to start, but please bear in mind, however, that not everyone sees it as either important or even existent. So to start with the basic distinguishing characteristics, we have monolithic and non-monolithic architectures. By a monolithic application, I mean one that is deployed as a single functional unit, including user interface, business logic, and database connectivity. Distributed systems, on the other hand, are by definition multi-tier, with the user interface separated from the database connectivity, and with the business logic in one or both layers, or somewhere between. Where it should go is beyond the scope of this video. This is a more complete view of the situation. Yes, the primary division is monolithic or not monolithic, by which we mean distributed architectures. Within the distributed branch there are then service-based architectures and other types. There are 3 recognized service type architectures here, and microservices is a valid pattern but only one of the options. There are also other types of distributed architecture. In this video you will see a very brief outline of each of the types listed here. This is obviously my view, but similar views and interpretations can be found in many texts on the subject. There will be some links to further reading and research at the end of the video. There can be some variation in the way names are used for some of the patterns, but the intelligent viewer will work it out. I will start with monolithic architectures. The monolith contains everything in a single deployment unit. This is where most developers start, for obvious reasons. They are the simplest form of development and generally the quickest to deploy, but they can become a bit of a problem to maintain as they get older, with additions and extensions. This video is not about saying that monoliths are bad, because they are not. Monoliths have been around for a long time, and over the past few years there has been a tendency to equate monoliths with legacy. Yes, many are now a bit long in the tooth and do qualify as legacy applications, but the term monolith does not by any means mean legacy, and monoliths are still very much part of the current development landscape. In fact, in March 2023, Amazon rewrote one of their microservice-based systems as a monolith and saved 90% on running costs, as well as getting better performance. A link will be included at the end of the video for anyone interested in the story. The idea of a monolith is language and platform independent. It could be as simple as a single executable, or it could be a smaller exe with supporting DLLs and runtime packages. It could also be a collection of jar files, or a website with one or more HTML and JavaScript files with other supporting elements. It just depends on the development environment used. Other options are available. This is not an exhaustive list, just some examples. The thing to remember is that it is a single deployment package that contains everything necessary for the application to run and work. This shows 4 types of monolith, and I will briefly look at each. I have included the unstructured monolith because they are still alive and well in a project near you. The unstructured monolith is just that. It shows no organized structure of the code and elements within the application. The image shows calls and dependencies randomly across the entire application. This makes it a bit of a nightmare to manage over time. How do they come about? Well, if no design structure is deliberately applied, they will just happen naturally. At the risk of offending viewers, there are many self-taught programmers around who have no real knowledge of application design and simply do not know any better. There are also some ill-disciplined developers who should know better but appear not to care. Also, over time, older systems can lose their structure even though they started in a proper structured way. This pattern is also referred to as a big ball of mud, although it may just be a small ball of mud. Be in no doubt that this is still a common pattern, or rather anti-pattern, in use today. The layered monolith has an organized structure, generally depicted as horizontal layers. The GUI is separated from the business layer, which in turn is separated from the database layer. All of the business logic for all processes will be in the business layer, and the same applies to the other layers. The diagram here does not show a complete list of possible layers, just an example. How the application is divided up is up to the designers. An often perceived disadvantage of this architecture is that a change to, say, the orders process would have to be done in most, if not all, of the layers. So a good initial design choice, but a problem over time with difficult maintenance. The modular monolith is probably the most common monolithic pattern currently in use. It is generally depicted as either vertical slicing or as blocks, but the drawing style does not really matter. What the modular monolith gives is code clearly separated into distinct areas, often by domain, so customer, stock, orders, etc., but potentially also as smaller feature packages. The image shows an example of how this might be built, but the way the modules are defined is up to the designers. Communications between the packages should be through specifically defined gateways or access points, and not just random calls. Enforcing this separation makes the modular monolith much easier to maintain over time, as for example, an update to the customer module should not affect any other module in the application. Enforcing the separation over time is important in this design. The modules may be separate code units or design time packages compiled into a single executable. They may be runtime packages or DLLs, or just bunches of files. This will depend on the development environment and does not affect the logical structure of the application. The last monolithic pattern to look at is the microkernel architecture. In many ways this is similar to the modular monolith that we have just seen. The key difference is that in the modular monolith all modules are required and must be included in the deployment package. But with the microkernel, the modules are linked in using some kind of plug-in mechanism, and therefore only some modules may be deployed in any given installation. This kind of architecture is suitable for situations where some clients and customers, or perhaps some users, only require some of the available functionality. So a quick summary of the principal identifying characteristics of the four monolithic architecture patterns we have looked at. If in doubt, stick to the modular monolith, unless you need the variable deployability options of the microkernel. Monoliths tend to be quicker to market, so cheaper to develop. They do, however, tend to become more difficult and more expensive to maintain over time. Like everything else, the more effort you put in at the start, the better it will be in the long run. Also, the monolith generally does not scale very well. One last point while I'm talking about monoliths. In distributed systems, the naming and discussion is usually about the server side, and the client is generally ignored. All of these monolithic types can apply equally to the client-side applications in a distributed system, simply by replacing the database connection with a connection to the application server. And part 2, distributed systems, where we will look at the server-side elements of the process. There are two distinct groups of architectures here, those based on some kind of service and others, starting with the service-type architectures. The service-oriented architecture, or SOA pattern, has been around for about 20 years now and features an enterprise service bus which orchestrates the associations between a number of business processes and application services. This is much more than just a message queue. These tend to be large and cumbersome systems that were popular for a while in some situations where integration was important. This is not really a single application architecture, rather more a mechanism for linking disparate enterprise systems. Domain services, or service-based architecture. This pattern has a separate server for each domain or partition. I call it domain-based because 90% of the time the partitions will be based on domains, but it is not a requirement as such, and service boundaries can be wherever you want them. Each server has all of the functionality required to support the domain or partition processes. These were originally known as service-based systems and still are in some examples. There could be anywhere between 1 and a dozen services, although typically it will be 3 to 6 services for most systems. Services should be completely independent, updatable and deployable without affecting any other part of the process. This architectural model is over 25 years old now. I started using it over 20 years ago and it was not a new idea then. Microservices, or real microservices. The clue is in the name, micro meaning very small or tiny. Real microservices evolved from enterprise Java beans, EJBs, where one bean equals one service, and are still more or less restricted to the Java world. Real microservices are single function processes, and a typical microservices system will have hundreds or thousands of services depending on the size of the system. Real microservice-based systems are very complex, probably the most complex and expensive systems, both in terms of creating and maintaining, and are only really a viable option for a small number of very large systems. Most systems described as microservices are in fact domain services, and the owners are better off because of it. Where did the confusion come from? Microservices evolved about 10 to 12 years ago in the Java world and started to become popular, or at least fashionable. Not wanting to be left out, Microsoft simply redefined microservices to be something that could be done in Visual Studio, in this case rebadging any service-based system with more than one server element. This can be seen in Microsoft Docs from around 2015-16 onwards, an exercise in service washing which has generally been quite successful. Lesson 114, that is 114, on the Developer to Architect website gives a 10-minute presentation on the principal differences between the two. Links at the end of the video. As I said at the start, I have looked at quite a few sites related to software architecture and have seen a few different ways of labelling the service types. Starting with the idea that all distributed systems are microservices, one site also labelled monoliths as macroservices. Personally, I regard both sides of this statement as silly, but that is just my view. If, however, you believe that all distributed systems are microservices, then any other terms must apply to monoliths. Next, we have the view that there is only one type of service-based architecture, and this is called microservices. Again, this is fundamentally flawed because there are three clear and distinct forms of service-based architecture shown here, and only one is really microservices. The clue is in the name, and the history is easy to find if you look. What I have called domain-based services were originally known as service-based architecture and still are in some places. This was okay as a name originally when it was the only type of service-based architecture around. I find it confusing now as they all appear to be service-based, and I generally use that term to cover the whole group of service-type architectures. Just remember that naming in the services world is not universal. The programming world, an area in which accuracy and precision would be expected, can be very sloppy about naming at times. I have seen one instance where macroservices was used to describe the SOA, mini-services was used to describe domain-based services, and microservices was used for real microservices. Personally, I think that SOA should just be dropped out of the picture now. I have seen domain-based services and real microservices labelled as macroservices and microservices respectively, which does seem to be near the mark, and another site I found added mini-services for subdomain level services. 3 words, macro, mini and micro, each associated with the service type of relative proportions. This is the best naming convention I have come across, or at least the most intuitive, and is my favourite. I wish that I had come up with this, but I did not. I am, however, going to borrow it and use it from now on. At the end of the day, it does not matter. All that matters is that for any discussion on services, the use of the term is clearly understood within the scope of the conversation. And on to non-service-based architectures. The distributed monolith, what is that? Again, searching the web or watching videos will get you a number of variations of what people use this term to describe. Here are a couple. Sounds like an oxymoron, a contradiction in terms. How can it be both a monolith and distributed? The simplest form of distributed monolith is a normal monolith where the database connectivity has been extracted to a middle tier, giving a monolithic client talking to a single monolithic server, which in turn talks to a monolithic database. This is usually an intentional monolith and is not necessarily bad. If that's what the plan called for, then do it. The other kind of distributed monolith is the accidental kind, and usually results from a failure in the design and build process. The intention was a service-based system of some kind, but instead of keeping the services as independent modules, all kinds of interdependencies have been created between the services. This represents the worst of all possible situations. Yes, some communication is expected between some services in a real microservices system, but not to the point where it becomes spaghetti soup. Space-based architecture is a memory-based system where the client-facing functional processes are created and dropped as required. These interact via messaging and are linked via a common spine which handles the data and communications. All data is kept in memory, so it can be very fast and it can scale well, but is complicated to build. Database interaction is done by asynchronous background processes. This architecture is seen as not working well for large databases. This is where I want to put the event-driven architecture pattern. Many of the sites and docs I have seen on architecture do list it as a distinct type, but I regard it as a second-level architectural pattern to be used in conjunction with or inside of one of the principal architectural types shown already. It does not describe the physical architecture, but instead describes a processing methodology, usually an asynchronous design using either notifications or messages, and with eventual consistency. It is a qualifier for an element of the internal structure of the system. It will always be an event-driven something, and just saying it is event-driven simply does not tell anyone whether it's an event-based modular monolith or an event-based microservices. CQRS is also listed in some places as an architectural type, but again, I do not see it as such. To me, it is another second-level architectural pattern that acts as a qualifier about some aspects of the internal structure of the system. It describes the idea of having separate data pipelines for read processes and transactional data. I used this pattern 20 years ago without knowing that it had a name. It is not just talked about as a specific named pattern now. Micro front ends, which I have seen referred to in documents as UI fragments, although that immediately leads to confusion with Android fragments, which are not the same thing. This has been around as a generic design pattern for 25 years, but is now getting a new lease of life in the microservices world. I include it here to show that it has been considered and largely ignored. In the structural sense, a section of the user interface is constructed as a separate entity along with a dedicated data connection or process and the database elements. So vertical slicing, but in smaller chunks. In the last few years, it has been introduced to change the way microservice-based systems are constructed. Where traditionally there would be front-end teams and back-end teams, the new idea is for one team to build the vertical slice, including the GUI element, the back-end service and the database elements, all together in one go. This is not an architectural change, as it's still a microservice architecture, neither is it a new design pattern, but it is a change in the way the development is managed. A link is included at the end. RAD. RAD is certainly not an architecture, although some may consider it a design pattern. Really, it is just a way of working. I am including a couple of modern terms that people may be unsure about, just to exclude them from any list of application architecture types. A service mesh is a management or control layer inserted over microservices to improve the management of certainly dozens, but probably hundreds of small services, many of which will need to interact with other services. The service meshes are proprietary software provided at cost by the large cloud providers, so not part of any microservice development process. Secondly, the data mesh architecture, which describes the domain-based partitioning of the analysis of data lakes, and has absolutely nothing at all to do with application architecture, which is what this video is about. And finally, to some links for extra reading or viewing for anyone who may be interested. These links all worked at the time the video was made. As I said at the start, I've collected ideas and opinions from around the internet, but I have obviously only managed to see a small percentage of what is available, and I've only listed a few of them here. How do such varied views come about on a topic that should be quite standard? At a guess, either the subject is not taught, or where it is taught, it is not taught very well. Apologies if that offends anyone, but that is what I see. If you search for modular monolith or microservices, for example, you will get a lot of links to sites displaying the author's opinions. One link for each of those types is shown here. If you only go to one place, go to the first one shown here, developer2architect.com/lessons. It is a list of short 10-minute videos on the whole area of software architecture. Lesson 114 covers the principal differences between macro and microservices. If you did not like my view of services, spend 10 minutes of your time watching this. There is a link to the story about Amazon replacing microservices with a monolith. The micro front ends link is a page or site devoted to this topic. If you're interested, start here. At the bottom there is a link to a random site with alternative views or way of expressing things. I could have picked any one of many and picked this one at random. Make up your own minds. On the videos page, the modular monolith video covers more than just the modular monolith and is well worth watching, even if you have no particular interest in the modular monolith specifically. There are a couple of videos labelled Part 1. It is up to you whether you carry on to Part 2 and beyond. These show aspects of other people's views on this topic. There is one on the accidental distributed monolith and how not to achieve it. The Lost Art of Software Design video at the bottom of the list is also well worth watching, particularly for Agile fans who believe that 3 months coding in order to save 3 days planning is a good way to go. Thank you for watching. I am always happy to discuss any issues arising. Look out for other random videos that I am doing.